Right now we are going to talk about the most central, the most critical, the most important concept in this course, most important, critical, central concept in all of finance, and that is present value. Present value is basically what is the value as of the reference point, and it's often today, of some value or some cash flow that occurs later or at some subsequent point in time. And so this is really the piggy bank example. Remember, we had our purple piggy bank. We were going to get that money in 1 year from now, and we wanted to say, how much is that worth today? What's the present value of getting $100 in 1 year? How much is it worth today to receive $1 in a year? The process of actually determining that is called discounting, and we're going to learn how to discount in just a minute. The reason this at time 0 is the present value of this at time t when the appropriate rate, and we'll learn it's called the discount rate, is r per period, is because if we had this amount of money today or at time 0 and we were able to invest it at r per period, guess how much we would have at time t? That's how much we would have at time t. So that's why PV0 at time 0 is the present value of CT at time t. So this is the most important, the most central equation in all of finance. Present value at time 0, so we want to know the present value at the reference point, is equal to C sub t, so that's the cash flow or the value, but it doesn't happen right at time 0, it happens at some point later on when in t periods. So now we're going to show you how to actually discount that. We're going to divide by 1 plus r, and r is what we talked about before. It's called the discount rate. You can think of it as an exchange rate between time periods. It helps us equate or find the equivalent values of a cash flow at one period and a cash flow at a period before. Sometimes it's called the cost of capital or the opportunity cost of capital. But we also want to take into account how much time it takes before that cash flow gets paid. And that's why we divide by 1 plus r to the power of t. So the longer it is till we get our cash flow, the more we discount, the more we're dividing by more 1 plus r terms. And we're going to look at the present value if it's based on actual returns and cash flows. You know everything that's going to happen. You would apply the same formula. If you don't know what's going to happen, you make your best guess and you use expected returns, expected cash flows, expected values. So let's take a look at our piggy bank. Suppose the discount rate's 10% and you're going to get $100 in 1 year. That's our purple piggy bank. And under this condition, the purple piggy bank is worth $90.91. $100 is what we'll get, but we're going to get it in 1 year. So we discount it by 1.1 to the first, and it's worth $90.91. And the reason, if I had $90.91 today, and I could invest it at 10%, 1 year later, I would have $100. Let's take a look at our yellow piggy bank. In this case, it's consistent with what you guys said, is that it's worth $62.09, which is less than the purple piggy bank. So you're going to get $100, but you're going to have to get it in 5 years. And so it discounts by 10% each year, $62.09. So again, the reason that that's the present value is because if I had $62.09 and I could get 10% each year for 5 years, I'd get 100. And so what it really comes down to is we would be indifferent, and the reason we would pay $62.09 for a $100 piggy bank is because if we had $62.09 and we bought a piggy bank for we bought a piggy bank that had $100 in, and we waited 5 years, and then we cracked it open, we'd get $100. Alternatively, we could say we're not going to buy the piggy bank. We take the $62.09, take it to the bank. They would offer us 10% per year. When we showed up 5 years later, they would give us $100. So you could either spend the 6209 on the piggy bank to get 105 years, or 6209 in the bank and then show up later and get $100 in 5 years. If we wait 20 years, the piggy bank's only worth $14.86. You're getting your same $100, you're still discounting by 10%, but now it's discounting for 20 years. And again, if you had $14.86, went to the bank and they offered you 10% per year, you show up 20 years later, you'd have $100. When you see the terms value or market value, they refer to present value. So if the value of an investment or the value of an asset is this, the market value of a stock or a bond is this, that's the present value. Unless you're explicitly told it's the future value or the book value or the face value or the par value or one of the other explicit kinds of values that we're going to talk about in this class, if it just says value, that means present value. When we're wearing our finance hat, which we wear in this class, and we're trying to make decisions that maximize value, and we're evaluating multiple choices, and we can only choose one, we're always going to take the one with the greatest present value. And if we're looking at opportunities or options or assets, if we see that the present value is positive, that's associated, that's consistent with a cash inflow. Remember, positive means money coming in. If it's negative, that's associated with a cash outflow. So real quickly, let's go over some basic decision rules. If we're comparing assets or options with a positive and we had a choice, we would want the one with the higher magnitude. You can imagine, would you rather get $8 or $5? You'd rather get $8. If you're comparing a choice that has a positive present value with a negative present value, clearly you'd want to take the positive. Not only is 2 in this case greater than negative 2, but would you rather receive $2 or would you rather pay $2? I'd rather get $2. And finally, this is the one that can be the most challenging, and if you understand it, it takes it away, is when you're dealing with negative present value, which is comparable to paying out money, you want the one with the smaller magnitude. So again, if you draw a number line, you got 0 up here, you'd have -5 here and -8 here. You can see -5 is greater than -8. But beyond the numbers, if I gave you a choice, would you rather pay me $5 today or pay me $8 today? I'm assuming you'd say you'd rather pay me $5 today. So when you see those negative present values, it's comparable to how much you would pay, and we obviously want to pay as little as possible. If we had choices with the same present value, we'd be indifferent. So if I gave you a choice, I said, look, I'll give you $100 in 3 years or $150 in 5 years, and you figured out the present value, given the discount rate, and you said, hey, they have the same present value, you would be indifferent between those choices. The fact that one's higher than the other, the fact that one's sooner than the other, they might even have different discount rates, the two options, all that's taken into account, and present value really gives you apples to apples to make comparisons. In our financial calculator, again, we're going to assume payment 0, so the modes are relevant, and we're going to basically give it the cash flow. We're going to give it T, the number of periods after time 0 when this value or cash flow is expected, and we can solve for the present value. So FV is what that value is or what that cash flow is, and so if it's a cash outflow, we're going to be paying money. We'd type in a negative number. If it's a case where we're going to get money or it's the value of something we own, we put it in as positive. N is the number of periods relative to the reference point at which the cash flow or the value takes place. I% is the discount rate. So you give it FV, you give it N, you give it I%, and you go ahead and solve for PV, and what's going to pop up on the calculator, because of our sign convention, you're going to get the opposite of the present value of FV discounted by I% per period for N periods. So let's do an example. In 3 years, you just got a bonus at work where you're going to receive $37,000 in 3 years. The discount rate on this is 11%, and it's a little piece of paper. How much is that piece of paper worth? Well, it's now worth 37,000 because you got to wait 3 years. Specifically, it's 37,000 divided by, you have to wait 3 years, discounted at 11% per year. It's worth 27,054. Now let me ask you a question. Suppose the company came to you and said, look, we know employees don't generally like to wait 3 years, and so we're willing to offer you a bonus today, and we'll let you have 27,000 today. Would you take them up on that offer? Would you rather have 37 in 3 years or 27 today? And the answer is that you would rather have 37 in 3 years, because 37 in 3 years has the same value as 27,054 today, which has more value than 27,000 today when the discount rate's 11%. So again, here you're being asked to compare two alternatives which are hard to compare at first, 37 versus 27, wait 3 years versus get it today. But because of present value, it allows you to make a value maximizing sound decision. If you want to use your financial calculator, you'd receive 37 in 3 years with a discount rate of 11%. There's no other cash flows. There's none of these regular interim cash flows. You solve for PV and notice you get the negative sign, so it's the opposite of the present value of this. So the present value of 37,000 in 3 years at 11%, 27,054. In 16 years, when your daughter goes off to college, you anticipate she'll need 250,000. You can earn 6.5%. How much you need to invest today to have just enough in 16 years? This is the definition of present value. The present value of 250,000 in 16 years when the discount rate is 6.5% is the present value is the amount that you would need to invest today, such that if you could earn this rate, you would wind up at 250,000. So again, 250,000 is what you're going to need in 16 years. 6.5% is the discount rate, discounted for 16 years, 91,274. Use the financial calculator. You need 250,000 in 16 years. Discount rate is 6.5%, 91,274. And if you want to go ahead and double check it, you can say if I put in 91,273.83 and I can earn 6.5% for 16 years, what does it equal? You should get 250,000. You may be a couple of pennies off because of rounding, but you're going to get something really, really close to 250,000. And again, that's why 91,273.83 is the present value of 250,000 in 16 years when the discount rate is 6.5%. So now you just bought a new computer, discount rate 7.2%, but you're given two options. The first, you can just pay up $1,200 today. Option two, you can wait a year and pay $1,300. So it's not clear, because option two lets you wait a year, which is a good thing, but it makes you pay $1,300, which is more than $1,200, which is a bad thing. So how do we go ahead and solve this? We want to choose the one which has the higher present value. And notice, since these both involve payments that we're going to have to make, we're going to still want the one with the higher present value, but it's going to be the one with the smaller magnitude. Which one involves paying out the least amount of value? So let's go and find the present value and compare them. Well, option one, paying out $1,200, what's the present value of the cash flows associated with that? Negative $1,200. That's easy. The present value of paying $1,200 today is negative $1,200. Option two, we're going to be paying out $1,300 in a year. The discount rate 7.2%. So paying out $1,300 in a year is equivalent to paying out $1,202.69 today. So now we got apples to apples. Would you rather take option one, which is equivalent, because it actually is, paying out $1,200 a day, Or would you rather take option 2, which is equivalent to paying out $1,212.69 today? Well, I would rather, and I have my finance hat on, pay $1,200 than $1,269. So I'm going to choose option 1. And again, if you have your number line, you got 0 up here, you got negative 1212, and just under it is negative 1212.69. So 12 negative, oh, not 1212, 1200. So again, even though it may look, well, 1212.69 is bigger, it's negative. So you can think of it as it's deeper. It's further away from 0, down, as you go down. If you want to solve it in your financial calculator, in 1 year, you would have to pay $1,300. Notice the FV is negative. Discount rate of 7.2%. Solve for PV and you get 1212.69. Notice PV is a positive because it's the opposite of the present value of negative 1,300. So you got to flip the sign. The present value of paying 1,300 in 1 year at 7.2% is negative 1212.69. So again, it leads to the same conclusions.